Why don't we just get a normal hobby like mountain biking or something? Why are we taking apart car batteries? Hanging on the wall behind me is a state-of-the-art battery from a £90,000 Jaguar I-Pace. Now that Jaguar unfortunately got into a bit of a car accident and was written off, but the battery is completely undamaged. Rather than just scrap it and waste it, we're going to try and repurpose it to see if we can get it to power up a building. I don't know if at the end of this video we're going to actually have a working system. I have no idea. Are you confident it will happen?
No.
The secret is I'm a massive dork.
Error.
And we're red.
It's the face of a disappointed man.
Can we do it?
Yes! Go on, mate!
You heard it! I actually think this is going to work. Right, so we'll start by addressing all of the naysays. Yes, I'm very aware of the new battery document that has just come out surrounding safety with using batteries. However, we are literally in the middle of nowhere. It's a very beautiful forest that we're in with nothing around, no residences. We're only connected to a residence electrically, not through any actual part of the building. So it's about as safe as you're ever going to be to experiment with something like this. And that is exactly what this is really. It's just a bit of an experiment, a bit of research and development to see if rather than just get this scrapped, we can actually use it. So let's start by showing you exactly how this battery works. On the top, right here, you've got this. So this is a flow and return for a cooling and a heating system. So you see you've got the temperature here for the inlet valve and the outlet valve. Those of you with an EV will be familiar with on a really cold day, on a really hot day, when your car is making all that noise, that's basically your battery being kept at the optimum temperature to run. Not only that, it's huge, right? This is 90 kilowatt hour battery pack. Imagine how much that would cost you on an ordinary setup. The other thing is it's designed to withstand a car crash. What you can see behind me, this is not actually the battery itself. This is actually just a casing containing all of it. I'm gonna flash a picture on the screen now, which shows you what the inside of this looks like. But basically it's lots of 11.6 volt cells with bus bars and sensors and things in between it to this outlet port here. So it's running at 400 volts. Thank you very much. Now for us, the reason why this is so good, right, is because this battery was effectively for free. The customer bought the car as a write-off, so we got it for extremely cheap to repair another vehicle, and it came with that battery. So we thought, well, we've got 90 kilowatt hours of battery storage, we've got the perfect place to put it. The guy has a huge solar array, generating way more solar energy than he's ever going to be able to use. Why not use this to try and connect it up to his building? So in theory, it should be really easy, right? So that is the objective basically, connect this thing up to his solar so that when he's generating excess, he's able to store it in this and then use it later. I don't know if at the end of this video, we're gonna actually have a working system. In fact, I have no idea. This is completely experimental, completely just something we're trying. So we thought, you know what, you can join us for the ride. Problem number one, actually, should we call it a problem or should we call it a challenge? Challenge number one. This battery is used to speaking to a car, and in case you've noticed, a house and a car are slightly different, but while we're on the subject, how beautiful is that triumph? Cars generally speak in a language called CAN. Now, inverters and domestic household solar generally speak in a language, well, or in a protocol, I should say, called RS485. Am I speaking right there?
Yep, that's correct.
So this device here basically is an Arduino board, so it's called a LilyGo, and it already comes with the CAN in and RS485 port out. So what we have to do basically is connect this up to the CAN port on that battery to access what's known as the CAN frame. Then we want to flash onto this a piece of code which will basically take all of the relevant CAN information and port that across to RS485 and vice versa to enable the car and the battery to speak itself. So basically we bought two of them in case we blew one of them up, and we've just literally got it connected up to a 12 volt battery. Right, Mr. David, what exactly are we doing here?
There's a project on GitHub which allows us to do the communication between CAN bus and RS485. So we need to get that onto this Arduino. Once that's on, we will attempt to connect this to the battery, and hopefully we will start seeing some information coming from it.
This is David. He has actually been on the channel before as a friend of mine. Basically, it's always good to have someone smarter than you around. It's not very hard, to be honest, but he's the guy who is here just to help me. He's not an expert at this, and neither am I. To try and find an expert at this has been an absolute mission. There are some people that have done things similar to this. I've messaged them, I've emailed them, I've tried to get in touch with them, and I can't. So we're on our own. So yeah, me and David are going to see if we can do this and take the EV battery to Homeworld by storm. Ready when you are, let's flash it.
Error.
Oh, well, that's not a good start. When you're working down on the south coast, the only thing you have to contend with is there is always a lot of donkeys around. I don't mind, I find I fit in quite nicely. I can honestly say this is the first time I've had donkeys and horses following me around at work. This is absolutely brilliant. Right, so we've managed to flash all of our software onto the Arduino board. So now what we want to do is to connect the actual battery itself to that board. So we've got this, which is like a little pin-out map. You can see every single one of the pins on the connector into that battery, which is what David is just working on at the minute, is mapped out as a specific thing. So you've got like feed into the contactor, feed out of the contactor. And what we have here is another one for a Hyundai. Now, the reason why we're referencing the Hyundai one is because someone has already cracked the code on the Hyundai, and that is the same battery chemistry as that. And in theory should be the same BMS system as what is in that battery. Some guy called Dala the Great, and he is clearly a genius with this stuff, but it's really hard to get hold of. But we're trying to copy as close as we can what he's done on his pinout map across to ours. So all that's left now is just to solder it on. So obviously the soldering that we're doing here is just temporary. These wires are not the right gauge or anything like that. We just want to see if we can actually get onto it. And that pin that you saw the pin out of earlier is for that connector just there, which David has been absolutely fantastically soldering onto. He's even got a chair. Look at this, absolutely brilliant, with that beautiful Triumph in the background. Oh, I love it. So yeah, it's a bit of a scatty video and I apologise for that, but that is because we are basically just tearing things apart, measuring things and trying to figure things out literally as we go. But I think this is the next step. Once this is soldered, we can get that into the Arduino board and see if we can wake the CAN frame up. Okay, so they are all soldered on. So now, if I just explain what exactly it is that we're trying to do with this tinkering. Pins number 1 and 18 here are the positive and negative of the contactor. So in theory, they need to have 12 volt power to be able to close. I could be so wrong here, but my thoughts are if that's like the A1, the A2 of the contactor, then it needs that power to close, right? And then we also have some external battery management system power, which is required, 12 volts. So we've given that 12 volt, and we've literally just hooked it up to this battery here. So the CAN side of it, what are we doing there, David?
So we've got a high and a low connection for the CAN bus, which we need to connect into this connector, which then goes into our Liligo board here. Yeah. This should then enable the CAN information to come through here, and this Arduino will be able to see that, and obviously the programming can then do something based on that information. So we're just going to power the Liligo board with a USB supply. It does work on 5 to 12 volts, but typically these batteries will output 13 volts. And if you give it 13 volts, the likelihood of it frying is quite high.
Let's power it up. There we go, we've got an LED indicator. So is that flashing yellow or is that flashing green?
It's supposedly green, but it does look a bit yellow, doesn't it?
Or red.
Okay.
Right. Okay, that's interesting. So I don't know if you can see that, but that is showing red, which means green if all is well, blue if CAN wires are disconnected or if something's wrong, yellow for warning, and red for basically fault state. And at the minute, it is showing a solid red. So something is not right inside of there. And I guess maybe that something is that there's no wheels, there's no brakes, there's no roof.
I think we need a terminating resistor for the CAN bus as well for it to be able to communicate properly. So that is probably why this is in a fault state.
Right, okay, so that Liligo is basically still flashing red, which is saying that there is a problem inside of this battery. However, there should be an end-of-line resistor across the CAN. Now, whether or not we need to add that or whether or not it's in here is what we're trying to establish. So there should be a 60 ohm resistance reading, basically, at the end of this, if it is right. And at the minute, this is showing as open circuit. So I wonder if we've just got the wrong pin on the pinout.
There's another internal CAN network with the battery system, which is probably worth a shot. So that is showing that we have a terminating resistor in that internal CAN network.
Well, that's good news.
Which is good news. So we could try swapping those cables over to those pins, see where we go from there.
Brilliant. Okay, new cable soldered on. Just moment of truth. I'm not really expecting a miracle here. Red. There we go. Confession, we've already had a little bit of a go at this off camera. Starting with this project, we've absolutely had no idea where to begin really. We've had to strip back as much of the battery as possible to understand how the actual components of the battery work, to see if there's anything we can override, anything we can adjust or change to get it going. Out of these two terminals here, we get, when the fireman switch is on, just under 400 volts DC. So this does work. But the question is, if we were to connect straight onto that, how will we get that to talk to the inverter? Because all of these cells, all of the temperatures, all of the voltage references, everything else is coming back to this battery management system. So we need that BMS to be on there, but the BMS is all outputting in CAN. So yeah, I'll show you the contactor setup. These are the two pins here that connect in and get the 400 volts. And then from what I can understand, it is diverted, managed, fused, etc. to these outputs here. Those outputs connect onto these three outputs here, and they are literally just like a bus bar that goes all the way up to the two motor connections at the top there. We were looking at this to see if there's any components or any bits and pieces we could maybe adjust, because you have a relay just there, or a little contactor just there. You've got another one there, got an auxiliary contactor there basically, and then you've also got these shunts. So these, I mean, technically that would stop power flowing back that way, right, in theory. I'm thinking, well, actually we might want power to flow back that way, especially if we're actually charging it. So could we connect up a car charger, replace that with a Zappy, when he has excess power, charge the battery through its ordinary charging bits and pieces, because we've still got all of the guts from this car. This was all connected up into the car itself. If we connected back up that charging module, could we charge the battery normally and then use the motor output straight into an inverter like this and then put that back into the house? I don't know, to be honest. Do you?
No, me either.
Why don't we just get a normal hobby like mountain biking or something? Why are we taking apart car engines and car batteries?
Right, that's it.
Put that on then.
Let's get it on.
They're all plugged in, so maybe that will change something. And we're red. Alright, so my original plan when I was asked to help on this was, oh yeah, fine, easy, we just strip it back to its cells, put in a new BMS, connect it up through a Victron system, Bob's your uncle, Janet's your aunt. It's not that simple. All of those cells have some kind of micro BMS in them which are outputting all their data. So we are having to literally learn how this works at the same time as trying to learn how CAN bus works and somehow convert that into RS485 to talk to an inverter. Now, we've even tried ChatGPT, right? But the next step, the latest update is I've found someone through a friend of a friend of a friend of a friend who actually writes software for these things. And I've also managed to buy a manual which shows an explosive diagram of every single part of that. So hopefully, next time you see me, this rain will be gone and we're going to have a little bit of help. It's magic. We just have to spin. And it's movie magic. Look at that. The rain has stopped and we have our help. So Chris right here is an electronics engineer. He's absolutely, so far, proven to me to be genius, despite whatever he might introduce himself as later. I guess it'd be a bit narcissistic if you introduced yourself as a genius. Yeah. But he's been a genius because we have these pins here, right? So these pins correlate to these pins down there, which connect into the BMS, or the battery management system. Now this BMS then correlates out to this, which is like a power management system, which will manage the power out to the different motors and in from the charger, etc. Where Chris has come in extremely useful is there's a circuit board inside of here, which I don't really know much about circuit boards. To me, circuit boards is a bit of a dark art. That comes under electronics, which is, you know, sometimes they cross over, but generally it's a different discipline to electrics. So he has been able to go in and read it, find exactly which one of these pins correlate to the CAN bus chips, and now we are here with our oscilloscope. So Chris, what exactly are we doing?
So right now we've actually figured out there's 3 CAN bus connections into the battery, and we're just trying to decode the CAN bus information really and understand what's going on inside the battery.
Perfect. So we're livening it up with this. So with this, we're able to wake up the CAN bus by applying voltage to where we need to apply voltage to, and then we've got 3 separate CAN buses on there, so we are reading all of them. Now, why have we got a scope, Chris, to read CAN bus?
So the reason that I've got a scope on here is because we're not at the point yet where we can actually decode the CAN bus signals. At the moment, I'm just trying to understand whether there are actually signals there and whether it's actually doing something when we turn the thing on. Next, we're going to actually decode them and see what the numbers are doing on the screen, actually what the CAN bus is doing.
Fantastic. Let's get into it. So when I say wake up the CAN bus, what exactly do I mean by that? Well, what I mean by that is inside of that circuit board, that's inside of the BMS, there are some little microprocessors. Now, those microprocessors hold that protocol. So we need to wake that up so that we can then read it. So we're doing that by applying a voltage. You'll see on here, it starts at, well, we've just saw the end there of the chirp. So this is the processor outputting the CAN signals. So these bytes here. Now, because there's 3, we're trying to work out exactly which one of those we want to use, if not all of them. So at the minute, it's looking likely to be that one. So the next step will be to use this device here. Now, this device basically converts CAN bus into USB so that we can plug it into the computer so that Mr. Brainy here can read it and understand it. This is probably not a video for the people that are here for the entertainment. This is more just interesting, because the secret is I'm a massive dork. I love all of this stuff, and what I love is that I'm so out of my comfort zone here. Your comfort zone is a beautiful place, but nothing is ever going to grow there. We've connected on to the CAN bus. Now, using the scope, we've been able to determine which cable was the high and which cable was the low, because I should stop saying that it's programming CAN bus, because it's not programming it, it's interpreting it.
So this is a bit of software called SavvyCAN. It's free open source software to actually decode CAN bus and kind of monitor what's going on. If I connect to the CAN bus and turn the thing on, you should see all of the CAN bus messages that are appearing on the bus show on the screen. You see there's a word there that says error. That's not a word we like to hear. In that short 5-second frame, we've got 25,000 messages on there coming out of the battery, and we need to now figure out what they all mean.
Because this one is turning out no results, we're going to label that one up and we're going to move on to the next one, because if you remember what I said earlier, there is 3 CAN bus microprocessors in there. So we're going to try one of the other ones. I've got an update for you. Sadly, it's not an update for anything to do with the car, it's an update to do with the food. Right. Rate that brownie. What are we saying?
9 out of 10.
What would make it a 10?
More of it.
The thing is, I might not be very good at interpreting CAN, but I'm very good at finding good food places around. Best bacon roll I think I've ever had. Had enough oil to make a Saudi blush, but I enjoyed it nonetheless. So now, the next step is to get this thing put back together again. We'll reassemble this, wire it all back in. I'm going to put that on and see if it changes any of the CAN error messages. Alright, I think this is all built and back together now. It looks like something out of the Clone Wars. If I can do it one-handed, it'll be even more impressive. Sorry.
That's why we don't do things one-handed.
Let's have some fun. Just while I'm plugging this in, let's see what you would be seeing if this was a 360 camera. There we go, done. So that is this external box plugged in, and this is what I'm hoping we can use to actually plug in out into our inverter. All these error messages from the CAN, we don't actually know what's causing them, but I'm hoping it's just saying that this relay box is missing, and now that this is back on, it will start shooting out. Can we do it?
So it's now staying on for longer than 5 seconds.
Can we do it?
Yes, we can!
This is basically the wiring diagram for the car. Now, we don't really have the right to repair here in Europe, but America, they do. USA. So I managed to buy it for $20 with a VPN and get the manual over here. Now this is a complete wiring diagram for the whole car on a system level. What we are looking for is the pin that talks about interlock. So an interlock is basically a switch that will switch off everything. And I think, well, we think, and when I say we, Chris thinks that after we're getting 5 seconds basically of data come through on the CAN bus, and then it dies, nothing happens. But we want it to last a little bit longer than that. 5 seconds is context dependent, not a very long time. We reckon that if we short out the 2 pins that we now believe to be the interlock pins, that is basically, the interlock is basically saying we've not had a car crash, we've not got airbags blown, this car is not upside down, and don't worry, you're not mounted on a wall in a garage in the middle of the forest, in the middle of nowhere with strangers. Except you are, but we're going to short it out so it doesn't know that.
Okay, so I've shorted out the interlock pins. We're going to turn it on again.
Yeah.
Bang.
Oh, there you go. Data. And see if it lasts more than 5 seconds this time.
No, it hasn't.
5 seconds and it's died.
It's gone. We're going to try and turn the battery on and do that again. Can you turn her off?
Yeah.
And then we will go again.
Battery is switched on. Let's try that again. 5, 4, 3, 2, no. This is the face of a disappointed man. Right, so we've managed to get some CAN logs out of this battery, but not much. I think what we really need to do is get a working eyepiece, plug into the OBD port, get all of the CAN we can out of that, and then compare the two. All I need to do is get an eyepiece. But again, the beauty of movie magic is I just have to spin the camera and the problem is solved. Oh, there we go. Working eyepiece, isn't that convenient? Let's go jump inside. I wonder if it's weird for the car, especially with the whole Mrs. Grant analogy of consciousness, of sitting here, being able to observe on its front cameras, like the carcass of a beloved past Jag, probably from the same factory, sitting on the wall. That's like us sitting there with a skeleton on the wall.
Interestingly, we're only getting CAN bus messages from 4 parts of the car.
Right.
So maybe we're on the wrong CAN port of the car, because there's again 3 CAN ports of the car and we're only connected to 1.
Well, that one should be actually quite easy to access because that's the back of the car in the boot. So maybe if we open up the boot, there might be like a little lift up for the fireman's key, and then next to that another CAN port. Right. In here somewhere is a fireman's key. You would have thought they'd have it somewhere easy to access, wouldn't you? Surely it's got to be somewhere easy for the... No, it's definitely on the other side. Does this lift out? Yes, this lifts out. And it is still not there.
The next day, because Corey didn't film anything else, and this was the next clip.
Do you know what that is, ladies and gentlemen? That is progress. Good morning, we're back. So, last night I had to leave when I had to leave because I had a meeting for a project which is coming up, which you're going to see, which is very exciting. But Chris stayed and managed to find that port they were looking for. So this right here is the CAN bus port, which means we can now plug that into the computer. The reason why that's cool is because we can read all of those codes from the working car, find the one that says, look, battery, wake up, start, ignition sequence, and try that on this. And hopefully we can make the CAN on this stay awake for longer than 5 seconds. But Chris now is having a very, very well-deserved lie-in, which means I'm going to be mounting the inverter onto the wall, which feels like awesome progress. I actually think this is going to work, which is crazy because we've come from having no clue where to start to figuring out it's way more complicated than what we thought it was ever going to be, to figuring out, oh, there's actually 3 cans to get into, so it's 3 times more complicated than what we thought it was going to be, to, I reckon we can do this. Let's do it. So the inverter is this jobby. So it's going to mount on this. I've never actually used one of these inverters before, but it's the recommended one for this system that Darla the Great has recommended. Let's whack that on, shall we? Now you might find it quite funny that I'm so infused by having a big battery on the wall. Well, yeah, it's not just a big battery that's hanging on the wall, it's the future. This thing, think about it, there's millions of EVs out there at the minute. They're being made every single day. What is going to happen to all those batteries when they become obsolete, right? A normal engine, you can scrap it, you can do something with it. And okay, yeah, sure, you can probably get the raw elements out of this, but at what cost? At what labour cost? At what energy cost to extract all the cobalt and raw minerals out of this battery? How about when they drop to say 70%, 50% even of their shelf life, rather than just scrap them and get rid of them, how about we get the full use out of the energy that's already been put into this to create it? I actually had a Tesla once, but then it got stolen. I guess that technically makes it an Edison now. That's why I find this so exciting. And yeah, I am geeking out over it a little bit, to be honest, but I think that's okay, because I find this exciting. The thing is, that's a bit complicated. It's a very niche audience that can actually use it and enjoy it, because like not everyone is going to be able to hang a battery on their wall. I know for one, my little bungalow, I don't think there's any space for one of these, and it's not a product that I could necessarily sell the installation of, because I don't know how I'd even begin to insure it, to approve it, all those kind of things. I have no idea, but I see it as a start, and if it inspires someone cleverer than me to go and do something with it, then well done, mate. I'm happy with that. It's about the greater good. Oh, blimmin' left my hammer at home. Building IKEA stuff at the minute. I've just moved house, still within the same area, but everything is everywhere. I literally, yesterday I had no socks. If you see in the video, I was wearing no socks because I literally couldn't find my socks. That's how desperate the situation is. No, I'm not happy with those fixings. This wall is horrible to fix into. I've got some real meaty fixings somewhere. Where are they? I'm gonna go look for them. Boom, there we go. Those bad boys. That is called the I'm not going anywhere fixing. You want some? Right, let's do the trusty. Can it take my weight test? Solid. Loading struggle sounds. Is that it?
Oh yeah, it's on.
It came with fixings. We're going to wire out from this. We've got all of these tons and tons of CAN cables. Can we fix it? Maybe. I don't really see what purpose this connector is serving if we're just soldering onto it anyways. I reckon I'm going to take all of those off, solder straight through so that it's just cables, and then I can put it on some heat shrink and Copex and push the Copex inside, Copex down, along, clip, along, up, until we reach one of these, which will be the comms terminals. I think that's going to be the way to do it. And then for the power, we can come straight off, down, up, into some sort of junction box, Henley block. It's going to need to be something that can take a couple 100 amps and that can take 400 volts DC. And then out of that, into the inverter. Ahaha, look who has arrived. Chris,
Hello.
What have you been doing?
So last night we managed to actually take apart the car, find the CAN bus control to the battery that's in the car, and took all the bits out of the car over there. And the car is a right mess. I don't really envy who has got to put that back together. We've managed to get some CAN bus logs of the car itself, and we're going to just try and do some more of that now. So we've now got some CAN bus actually coming through now that we've turned the ignition of the car on. So we've got a number of messages. Now it's stopped. Actually, I think that's because you opened the door. When you open the door, we got 50,000 CAN messages in the car.
Done anything?
Thousands of CAN bus messages coming through as you speak.
Right, okay, let me close it again. Your car is plugged into that CAN port directly on the battery, not the OBD port here. So it's the same one as what we've been playing with over there. So I guess I just put my foot down and push the start button.
Not quite. So yeah, if you push the start button, there we go. We heard the relay click there. So I've got all of the messages.
It's that box just there, isn't it? We're trying to wake up.
Yeah, so there's a couple of relays inside the BCM which actually turn the battery power on. Yeah, so we're trying to turn that on. We'll find out the messages that actually make that turn on.
That box over there isn't outputting power. Now that's some kind of safety device, but we can obviously override those relays, but it'd be much nicer if we can keep them there rather than have to make our own safety devices. It'd be much nicer to use all of the safety systems that have already been designed by Land Rover, sorry, to fit actually inside of the battery. So we're pinging the contactors here, listening to them, what they say, what CAN message they output when they start up, and we're going to try and save that message and ping it to those contactors to see if we can get them to start up. By contactors, I mean just basically just a magnetic switch.
Can you press the stop button on the car, please?
Yep. Anything happen?
Nothing's happened as yet. Can you press the start button on the car, please?
Yeah.
So the safety relay didn't click that time.
I wonder if I started it or put my foot on the brake or something.
Yeah.
There's a lot of engine warning lights on, which I don't imagine are. I imagine it's completely to be expected. Maybe if I shut the doors, it will click the relays in. Oh, listen. Boop. Any noise?
Did you hear any relays clicking?
Didn't hear any relays clicking. Unless once you push it once, they just stay engaged.
Yeah, maybe. Is it possible for you to put the car into drive mode? I think you'll put your foot on the brake.
Put my foot on the brake and push it again.
Yeah. There we go.
There was the relay click.
That's it. So you have to have your foot on the brake and then press start for it to click.
Right, so now he's going to play back what he's just recorded into the car can here directly to see if he's able to trigger those contactors and those relays to start up and switch again.
Shall we see whether it works?
Yeah, mate.
So it's halfway through now and there's nothing. It's a good thing that nothing's happened.
Okay. I mean, I guess that nothing is a fire. There's no fire that's happened. That's good. Oh. What's that? That's the look of worry. Shall we save that look? It's coming from out here.
So
Stop now.
that is the same as, do you know when you were engaging the ignition in that same sort of frequency? So I think that we're playing back to the car and the car's trying to turn on. This is very interesting. We've made the car try to turn on, but it can't.
Chris very excellently described it to me earlier as CAN. Basically, it's like a network. He said it's like a group, community of people, all with different addresses and names, and they're all talking to each other, between each other. What we're trying to do is basically Trojan oi ourselves into the network and say, hey, I'm a nice friendly ECM, electrical control module. I am not a circuit board and you're not hanging on the wall.
Can you hear that? The relays are clicking on and off.
Yeah, but the relay's here though. Why are the relays here? It sounds like the charger. You're just impressed that something is happening.
I don't care about that because we've managed to get the relays to click from my laptop.
Oh, the relays were clicking?
Yes.
Ah,
Yes.
woo-hoo-hoo. That's no longer the face of disappointment.
Listen to this when I press play again.
Yeah, go on. Oh, I heard it.
You heard it?
Yeah.
Listen carefully.
Yeah, listen to it. Yes! Go on, mate.
Do you want to know what I'm going to suggest next?
A beer?
No.
Okay, so tell me what you're doing.
So right now I'm connecting up the laptop CAN bus adapter here into CAN so that I can play back the recorded frame that we've taken from the car and hopefully hear some relays click. The same as how we saw in the car.
Are you confident it will happen?
No.
Did plugging the car in with that code make the contactors click?
It didn't make the car click. We've found that there's a couple of other pins on the connector that might need some sort of rigging to see if we can fudge it into thinking that it's in the car.
I can show them. So there are these extra pins which do coolant levels and do all these various things which we weren't sure about. So we've run some wires, Jerry rigged them into the car to see if that pushing this ignition will start a sequence and satisfy that. Now, still not working very well. The idea was if that car is working and the contacts are all coming on and clicking, then obviously that is telling it we're satisfied. You know, there's no crash, we have coolant, we have everything we need to switch on and be satisfied. Still not working. However, there are a couple last little connections which we believe might need some sort of resistor to replace actually physically wiring it in. So we're just working it out now. So we need a 30k resistor, so having two of these 75k resistors in parallel. How does that work, Chris?
So two resistors in parallel just end up being half the resistance because the electrons go through half of the resistor at a time. And then we're just trying to find as well around 17 ohms in this lovely collection of resistors that I've got.
So why are we going 30k ohms and 16k ohms?
So that was what we've measured in the car to be on those pins to ground. So that's it, really.
Trying to recreate that,
Yeah,
basically.
just
So
trying to
this is
recreate
basically telling the car you are okay, but it's not actually okay. It's just these resistors. So we have our resistors there 2 in parallel on each of the ones, equaling the value that the signal that this was outputting to say that it's safe and satisfied.
I'm not safe and satisfied, if you're asking.
All right, Chris, what's happening?
So we're trying to connect to the battery using this CAN bus adapter. We're trying to read any fault codes that may be on there because we've got a list of fault codes from the manufacturer. So that's where we are at the moment.
Guys, remember when at the start of the video I said to you, I don't know if at the end of this video we're going to actually have a working system. Well, right now it's not working, but have faith. We have made leaps and bounds of progress. People said to us originally that we wouldn't be able to get the computer to talk to the car because of firewalls and all the rest of it. We've talked to this car. We've managed to get this car to work. The battery works. We've managed to get all the data out of that into CAN logs. We've managed to flick on and off the contactors, do everything in this car. So that proves that we are able to do it, but something is missing in enabling us to talk to this battery. When I say we've tried everything, I mean we have literally tried everything. We've tried various different resistors. We've been mapping out what's in that car, putting it over there, recording CAN pings and messages over there, replaying them over here. It's having none of it. Now, my question to you, if someone here in my audience is an expert with iPace or Jaguar, then please reach out. In the meantime, we're going to be carrying on with this, but thank you so much for watching. See you in part 2.
Bye.
Little life tip for you. A Stella Artois glass, the drink of legends, fits perfectly into a Milwaukee pack-out. Coincidence? It's up to you to decide.